Okay, so this is Bullseye's prototype, and it can be found at jimmorey.com/bull/simplebull.html. And so this is prototype over here on the right, and essentially it is under 1,000 lines of code, JavaScript, jQuery, and D3 data-driven documents, and um, it implements a game that is based on this concept of the bullseye. And so the bullseye is a node in this network that is surrounded by nodes of a particular with particular properties. And so in this case, this node 54 is surrounded by multiples of 11. Okay, and so that's the goal. And so just to see the goal again, here we're looking for multiples of 2. And so you can scan the network and you'll see that that's the only node that is surrounded by multiples of 2. So what we can do is we can change the difficulty of this content. And so in this case, we saw 2 and I forget, what was it, 11? No, anyway, whatever. The easy levels have to do with the multiples of 10, 2, and 5. And so as we go through, multiples of 5, pretty easy to spot because we just look at the last digit. And 10 is even easier. And so if we move on to normal, though, we now have numbers that are 4, 23, 9, and 6. And I think that the 3, 9, and 6 make it a little bit more complicated. And so here we're looking for 4. And so we get this node. And so let's see if we can find I'll just quit until we get well, multiples of 6. Let's go for 3, shall we? Look at all these. Come on. Okay, 9's okay. And so here, you just check the numbers and add up the digits and see that one of these is a multiple of 9. Anyway, that's the set of normal factors. Hard includes more tricky ones, 12, 18, 15, and 7. I think 7 is the most difficult one because what happens here is, of course, there is no real math trick to figure out if something's a multiple of 7. You essentially have to just recognize these. And so in this case, yeah, you might not have recognized that 91 is of 7. So anyway, so easy, normal, and hard, essentially the only difference is you change which multiple you're looking for. And so expert now includes all of these numbers, but with the twist that you now have 3-digit numbers rather than just 2-digit ones. Now, they are all under 200, and so it's not that tricky, but still it adds like it doubles the number of possibilities. And so in this case, we're an expert, so it just happens to be multiples of 5, and so not so hard. Now, when you go through all these, yeah, this is the worst one. Heading 7 with 3-digit numbers becomes a little bit more complicated. And so I should be able to figure this out fairly quickly. And so, yikes. What? Yeah. No. Anyway, that's another thing. You can see it figures out your mistakes, and really, oh, it's bad. This is very bad. I'll just quit. And how did I miss that? Okay, and so there's our content difficulty. Now, what's probably a little bit more interesting is changing this network, because essentially this network, none of these ones on the edge are possible bullseye, and so it's really only these 9 that could possibly be a bullseye, because none of the other ones are surrounded by 4. Here only 2, here there's only 3, and so you need 4. And so after a while you get to scan quickly and you get to see these things. And so let me just make this a little bit easier, and What we can do though is change the size, and so here is the medium size, and now you suddenly went from 9 possible bullseyes to 16, and so guessing is a little bit more not as a successful strategy, and so you have 16 things to do, and so the scanning algorithm becomes a little bit more interesting. And of course, you can go to large, and this becomes a little bit more a laborious task to find. With easy, it's actually not too bad because you can scan fairly quickly, but ultimately this just repeats the same task again and again. What makes Bullseye, I think, a little bit more interesting, or what I'm calling the curiosity magnet, is that we can change the geometry of the network. And so let me just push this back to medium and examine more interesting geometry. So here's one where locally each of these patterns has an X. And so in this case, we can see the bullseye is an X on its side. And so here, the X is on the other side, and then of course we have the standard X. And so there's 3 different orientations for these bullseyes, which makes it a lot more challenging rather than always looking in the same way. And so you have to sort of have a more flexible kind of a mind to be able to handle something like this new one. As well, you can go to, this is a symmetric kind of thing, an X, whereas if you switch to a K pattern locally, you can see that this K makes things a little bit more challenging as well. And so here we've got 3 different orientations of the K, and finding the thing becomes a little bit more challenging, I would say. And so similarly, my favorite is the piece local geometry. So here, the piece symbol has 6 different possible orientations. And so you can see as you walk around, you get 6 orientations. And so in this case, we're looking for even numbers. A search algorithm becomes not entirely trivial. In fact, if you can see, I'm sort of struggling to find this one quickly, and right in the middle there. So, but yeah, this is why I'm calling it the curiosity magnet, because I think it by being able to change these, you can get into some interesting patterns. And so some of these are a little bit more tuned in the prototype than others, because I don't quite like the borders of this one, but the pattern is quite interesting, because you can sort of see these parallelograms sort of connect together to make more. So let me just quit out of that one, and yeah, there it was. Anyway, so these overall patterns are defined by a finite state machine that allow you to sort of keep growing out. And so the ones that have been more, I would say, tuned are the piece, the K, and the other ones, and so the cross and the X. And so what's nice is when we change to a large, for instance, the borders are aesthetically pleasing, whereas some of the later ones I haven't got around to using a well-defined priority queue to expand in a way that still looks aesthetically pleasing. And so, but yeah, the reason why I can stay under the 800 lines of code is because the finite state machine defines these patterns, and I don't have to have everything written out in detail. And so, but yes, so network difficulty, definitely interesting. Now, the future of the prototype will of course be, rather than having these drop-down menus, that it'll be a more a level-driven thing where people maybe have some sort of leveling up, etc., to gain more of these interesting geometries, so that it's kind of yikes, that was a bit too big. So that they want to win to explore some new things. And so, um, anyway, the thing is, of course, because it's defined by a finite state machine, you could probably easily go to 3D to make some interesting patterns, but more perhaps interesting to many would be that you can change to um, vocabulary or a linguistic um, goals. And so in this case, for instance, you can see that you get a bullseye that have to do with words related to the body, and so elbow, jaw, hair, this type of thing, or farm things. And so here you're looking for, that one's wrong because of the desk. You can sort of see this one's wrong because of the organ, and so you sort of walk through there, and eventually you find out that it's this one here because it's got all farm words there. So essentially, this is a first preview of the prototype. Please take a look at the actual code itself, and hopefully there will be more to follow with more polished prototypes. Anyway, cheers. Read the paper.